How did applied math as a discipline come to be, and what did it become in the present day? In order to begin this expert to novice topic, let us first begin with one of the first applied mathematicians. His name was Joseph Fourier, and he made the majority of his advancements in the early 19th century. For instance, the Fourier series, which is a way to represent non-traditional functions with continued summations of the sine function, is portrayed on the right. Now, what this effectively means is that Joseph Fourier and his work was representative of a field that would originate in the mid to late 1970s, which is called applied mathematics, which is the topic of this presentation. Joseph Fourier effectively wanted to take the advances made in mathematical science and apply those to other areas of science and investigation in order to solve the problems that they were struggling with. So, for example, Lin, in his article on the role of applied mathematics in the journal Advances in Mathematics, argues that many scientists are unable to understand the mathematics necessary to solve the problems that currently bother them. However, many mathematicians are simply unable to understand the scientific implications of the mathematics they use. So applied mathematicians as a separate field, or applied mathematics as a separate field, should be instated in order to combat this problem and be able to apply the most recent advances in mathematical knowledge in the solving of the problems that those scientists were facing. So some examples of these problems would be weather forecasting, turbulence prediction, and numerical analysis and computing, which are all very lucrative areas of research today. So we can look at the development of applied mathematics throughout the late 20th century. So for instance, when Lin proposed such a field, it didn't take very long for the vast majority of universities around the country, Purdue being one of them, to adopt a department or field of applied mathematics as an area of study. And the figure above and the figure on top, I have a university who has since renamed one of their departments to Department of Applied Mathematics. And in the bottom, I have a figure that shows what areas of mathematical research applied math has carved out for themselves versus that which are reserved for more pure mathematical study. Now, the rise of applied mathematics has not come without its impacts on the scientific community as a whole, and such impacts are necessary when it comes to understanding the impact of applied mathematics as a discipline beyond simply just being able to solve problems that we weren't able to before. So, applied mathematics, according to Kapachova at least, on the importance of pure mathematics in the Journal of Mathematics and Statistics, argues that pure mathematical research has often been rendered obsolete or second nature to the research that applied mathematicians have been conducting. Now, whether or not this is true, he argues that many pure mathematicians have a perspective that applied mathematicians are the future, and many times they try to label their own research as applied research in order to, in their eyes, secure a more guaranteed avenue for their research. Now, whether or not this is true, we must recognize that applied mathematics in the fields that it holds within itself, in the diagram we see in the top, has fields which are much more readily available to application, for instance, differential equations and approximation theory. And in the bottom diagram, we also see that science, engineering, medicine, and all of these other fields are under the umbrella of applied mathematics directly, whereas pure mathematics do not have direct access to those very lucrative areas of research. So whether or not this statement is true, many mathematicians have looked at this information and they have believed that pure mathematics is starting to become obsolete as a result, and understanding that mindset from many pure mathematicians is essential to understanding the place that applied mathematics holds in today's academic literature. Now, finally, has applied mathematics invaded the scientific community? Well, an individual known as Batterman, in his article on the explanatory role of mathematics in empirical science from the British Journal for the Philosophy of Science, believes that yes, indeed, the applied mathematics has invaded the scientific community for worse. Now, on the left and on the right, I have two very well-known theories. On the left, I have general relativity, and on the right, I have string theory. And they are both represented purely mathematically. Now, Batterman argues that such a standard of representing scientific theories purely mathematically is indeed a problem. And in many cases, those mathematical models fail to address all the nuances that the scientific theory actually tries to represent. And as a result, he argues that mathematical models as a metric for the legitimacy of a scientific theory should not be used, and instead scientific theory should simply aim to describe the theory that the physical phenomenon that they are trying to represent. Many individuals do indeed disagree. For example, Vasquez in the article "The Importance of Mathematics in the Development of Science and Technology" references how the advancements in applied mathematics, especially computer simulations, for instance, has tremendously accelerated the development of scientific theory and research. And for instance, Bueno and Kolovin, from their article "An Inferential Conception on the Application of Mathematics," argue that instead of discarding mathematics or significantly decreasing its role, they should in fact increase its importance and its fundamental role in scientific description to a three-step process of inferential conception of a mathematical model. Now, there are those who have tried to bridge the gap between these two camps, such as Pincock in his article "A Role for Mathematics in the Physical Sciences," where he attempts to diplomatically engage a healthy debate among the scientific and mathematical communities on how important applied mathematicians should be to the areas in which they are trying to apply. So in many ways, applied mathematics has a disputed place, but a very necessary place nonetheless since its early inceptions. And applied mathematics today is a very essential area of research, but in many ways, its exact place has yet to fall completely into a decided area.